Hello everyone, welcome back to our channel again, Making Life Easier, and welcome once again into our Basic Mechanics series. Kindly subscribe to our channel, like and share, and also hit the notification button so that whenever we upload a video, you'll be able to get in touch with us. Today, we are looking at forces in 3D. So we are looking at resolving forces in 3D into components, that is in the vector form, using angles. So let's quickly run through our example. Example number 1. In the figure below, if the magnitude of F is 300 newtons, determine the components of the force. And we are given this diagram. So we want to find the S component of the force, the Y components of the force, and the Z component of the force. Quickly, let's look at how to solve such question. Solution. We have been given this problem, and then in this case, we have a single force. This is our force. And then we are asked to resolve this force into components. So just as you have seen, the object is three-dimensional. The object there is a three-dimensional object, and we have a force. So it means that our force will also be three-dimensional. And for that matter, we said that forces can be resolved into components. So it means that the force there can have the S component. It can have the S component in this axis. It can also have the Y component in that axis, and it can also have the Z component in that axis. And then you can see that in our axis we have X, Z, and then Y. So we say that this object is three-dimensional object. Anytime you are given a three-dimensional object and then you are asked to analyze, it is important that you express the force into components, which means that you express the force in the vector form. Now, if you want to express the force in the vector form, then you are going to use this formula to express the force in the vector form or into components. The formula is F in the vector form is always equal to the scalar force times lambda. And this lambda is what we refer to as the direction cosine. The direction cosine. We call it the direction cosine because it indicates the direction of the force with respect to all the three axes, with respect to the x-axis, with respect to the z-axis, and with respect to the y-axis. And so it is called the direction cosine. Don't forget that we said that forces are vector quantities. So it means that the point of application is always very important, and then where it is ending is also very important. So this direction cosine indicates the direction of this force, which we have been given in this diagram, and then we are told that the magnitude is 300 newtons. So basically, there are three ways of finding the direction cosine. There are three ways of finding the direction cosine. You can find the direction cosine using angles. So you can find the direction cosine using angles. And in that case, if you are using angles, then the formula is lambda is equal to cos theta xi, which this theta x is the angle the force makes with the x-axis, plus cos theta yj, and cos theta yj is the angle the force makes with the y-axis, plus cos theta zk. And this cos theta zk is the angle the force makes with the z-axis. So in that case, when you are given the angles the force makes with the x-axis, the y-axis, and the z-axis, you use this formula. So this is one way of determining the direction cosine. You can also determine the direction cosine using unit vectors or using distances, using unit vectors or distances, using the distances. Good. So we can determine the direction cosine using distances. So in that case, it means that now our lambda will be equal to dxi over dxi, which means that the distance on the x-axis, plus dyj, which means that the distance on the y-axis, plus dzk, which is the distance on the z-axis, all over the magnitude of the distances d, where we can say that our d will be equal to the square root of the x square plus the y square plus the z square. And from here, we can also get our directional cosine. And the directional cosine can also be determined. So it means that from here, dxi over d is the same as cos theta xi. dyj over d is the same as cos theta yj. And dzk is the same over d is the same as cos theta zk. We can also determine the direction cosine using forces. So in that case, our direction cosine will be equal to the force in the x-axis plus the force in the y-axis plus the force in the z-axis over the magnitude of all the forces, F, where in this case, our F will be equal to the square root of F s square plus fy square plus fz square. So all these methods, all these three methods, the angles, the unit vectors or the distances, the angles, the distances, and the forces can be used to determine the direction cosine. When are you going to use each of the cases? It depends on the question which you are given. So in this question, we have been given the angle the force makes with the x-axis, which is 40, the angle the force makes with the z-axis, and the angle the force makes with the y-axis. So it means that in this case, we are going to determine our lambda using distances, So from there, let's look at how to solve. We have been given, in the question, we have been given the angles. So in this case, we are going to solve the question using angles, and using these details which you have been given in the question. So quickly, let's look at how to solve this question. So in this question, we have been given the angle which the force makes with the x-axis, which we are told is 40. So it means that this 40 will be equal to, so we can say that theta xi solution, we can say that theta xi is equal to 40 degrees. Our theta yj, which is the angle the force makes with the y-axis. So in this case, the angle the force makes with the y-axis is from this point to that point. And we have been told in the question that it's 65 degrees. So 65 degrees. And then we have theta zk, which is the angle the force makes with the z-axis. And this is the angle the force makes with the z-axis. So we are told that it is 150 degrees. So now we can say that our force in the component form, or our force in the vector form is equal to F in the scalar form times lambda, which is our direction cosine. And we know that our lambda, here we have been given angle, so our lambda will be equal to cos theta xi plus cos theta yj plus cos theta zk. And from here, we can put in, we know our theta xi, the angle the force makes with the x-axis, which is 40 degrees. We know theta yj, which is the angle the force makes with the y-axis. And we know theta zk, which is the force, the angle the force makes with the z-axis. So we can just insert them into this formula. And we are going to get lambda equals cos theta xi plus, sorry, let's put in our values. So our lambda will be equal to cos theta, we want to put in our values. We want to put in our values. We want to put in our values into the formula. So putting in the values into the formula, we are going to get lambda equals cos theta xi is 40 degrees plus cos theta yj, which is 65 degrees, plus cos theta zk, which is 150 degrees. And from here, our lambda will be equal to, so this will be I, J, K. So from here, our lambda will be equal to 0.707 I plus 0.423 G minus 0.866 K. So once you have been able to determine our lambda, then our force in the component form or in the vector form will be equal to, our form in the vector form or in the component form will be equal to F, we are given in the question that is 300 newtons times our lambda, which we have here, which now is 0.707 I plus 0.423 G minus 0.866 K. And from here, when we multiply this by that, that will give us the S component of the force. When you multiply this by that, that will give us the Y component of the force, and this by that will give us the Z component of the force. So here, our force in the vector form will be equal to this times that, which will give us 212.1 I, and then the force times this will give us 126.9 G, and then the last one, which is the Z, will give us 259.8 K. So it means that what we have here is our S component of the force. This will be our Y component of the force, and this will be our Z component of the force. So we have been able to determine the component of the force or the force in the vector form using angles. That is pretty very simple. In our next problem, follow us. We are going to solve the direction cosine using distances. So you can see how to solve problems or to get a direction cosine using distances. Kindly subscribe to our channel as we bring you the best of whatever you need in basic mechanics. Once again, thank you for watching. Kindly subscribe to our channel, like and share as well. See you in our next video. Bye-bye.